about to go to our next talk, but before that, I wanted to let you know that behind this banner over here, by the exit or the entrance, depending on whether you're entering or exiting, you can find the Lightning Talk board. So far, we only have 2 submissions, which is pretty thin. I invite you to submit a Lightning Talk. It doesn't have to be about Python. It can be about Python. It doesn't have to. It's a very short talk. It's only 5 minutes. It doesn't have to be super well prepared. You can have slides. You don't need to have slides. You can do live demos. You don't need to do live demos. Just come on stage and talk about something you're passionate about. So the Lightning Talk board will stay here for the next 2 sessions. If you muster the courage, and I really encourage you to, come and sign up. And now I want you to give a warm round of applause to Samuel Colvin, who's going to tell us how simple observability can be made with Logfire.
Thank you so much for coming. I'm Samuel. I created Pydantic originally back in 2017 as a side project, and then we started a company around Pydantic the beginning of last year. So this is a sponsored presentation, so thanks for being here, but no fear, because I am not simply going to go through a litany of features. I'm going to show you a bit about why we built Logfire. Then I'm going to do a live demo that will probably go wrong, but hopefully will be more entertaining than just listing features. So what is a log? Like fundamentally, if you think of a log in terms of Python data structures, it looks something like this. It's kind of a list of tuples of 3 things, of a date time, a level, like info or warning or error, and then some kind of string that contains the message. And you can see what that looks like as an example below, again, in kind of Python syntax. But even here in this very simple example, we can start to see one of the many problems with logging. So you can see we have 2 different post requests. The log from them is emitted at the end of the request. And then just before it, we have this payment failed, insufficient funds. Which of the 2 requests does that relate to? It's basically impossible to tell, assuming that the timestamps are close enough together, which we assume they are. So logging, as we see it here, is really roughly what code looked like until, well, even in the 60s, people were coming up with Fortran and realizing that a linear list of instructions wasn't that good, and we wanted subroutines, we wanted structure, we wanted nesting in our code to make it easier to write and to read. But the problem with logs is, for most of us, they really haven't moved on since that same original data structure of a simple linear sequence of events. So what should a log look like? This is an alternative, again, using Python syntax, description of what we could imagine a way to, in the abstract term, log our application. So we have a timestamp, like we did before, but we don't just have one timestamp, we have the option of having 2. So now, instead of just recording a simple event, we can record the duration that some task took to complete. We again have the message like before, but we also have attributes where we can send some arbitrary Python data or data about what's happened in this particular event. But then really critically, we have children, where we have more logs associated with this log. And that starts to look more like this. So instead of simply just having to have the log of the request and separately the log of insufficient funds, we have our log about the reason that payment failed within the HTTP request that caused that. And suddenly, without even having to think about it, we know exactly which log this particular error, or sorry, which HTTP request and therefore which user this particular error is related to. Now, this thing is not called a log. This is called a span in observability parlance, and you put them together to form a trace. And what I'm proposing here is not entirely new. I'm not claiming for a second we invented this. Tracing has been around in one form or another since the 90s. But for most of us, and me included, until we had Logfire, when building an application, in general, you didn't have access to that because it was just too much faff to set up. So we were all using logging. And so the reason we built Logfire was to allow something more like this and a bunch of other advantages to be available to any Python developer, or indeed any developer, without the overhead of setting up a complex observability platform. So, Pydantic Logfire. The fundamental principle, and the thing we keep going back to, is developer experience. And the developer experience starts with being easy to get started. We are now obsessed by observability and how you configure it, but we know most Python developers aren't. They want to get on and build their app. Indeed, lots of people writing Python aren't even day-to-day Python developers. They're CTOs, engineering managers, quants, professors, people who are not even writing code at all in their day-to-day life, but they're using Python as a lingua franca of getting something done. It's like the successor to Excel in many ways, in a good way. And so simply making it simple to use is one of the fundamental things for us with Logfire. Secondly, it's built on top of OpenTelemetry. So OpenTelemetry is a industry-wide initiative to have a kind of common rails over which observability data can be transmitted. OpenTelemetry is an excellent principle, but like lots of similar designed by committee projects, it's a pig to actually go and use. So we make a nice veneer on top of OpenTelemetry. It's customized for Python. That's the SDK that I'll show you in a minute. But because we're built on OpenTelemetry, you can use it with any language. We do traces as logs, as I've sort of started to allude to, and also metrics. And we have, in particular, structured data, which I sort of, again, alluded to with the attributes. But instead of just walking you through each of those features and what they look like, what I'm actually going to do is give you a demo of using Logfire. So if I come out of there and I come over here and I have, well, I'm actually just going to run the app and show you what it does. So I have, can you see that roughly? I mean, you don't need to read the words particularly, but I have a simple web application. I'm built with Fast API, which I'll show you in a minute, and I'm running it here with UVicorn, and this is it running. So it's called Cat Bacon, and it allows you to generate an image of any animal you like in the style of Francis Bacon. So if we put in here dog, and this will occasionally crash, and probably it will now that I'm showing it to all of you, but we'll see. And so it goes off, and it uses OpenAI's API to generate there we are, great. I will hopefully show you why that is in a minute when I've managed to get one to actually work. We'll try fish and see if it decides that is better than dog. We'll go back here and we'll work out what's happening. Right, so let me try one more time and see if it has not done this all day when I've been trialing it, and it's effectively deciding that the prompt I'm generating, generate a picture of an animal, is breaching its rules on whether or not it's obscene content. I'll explain to you how in a minute. Fingers crossed it's now working. And when it's finished generating the image, you will be able to see what it's kicked out. So the internet's quite slow, very slow, but we get back a picture. We get back this image. And sure enough, the other very simple thing this app can do is show us the list of images that I've generated in the past, and we can go and view them. Now, what I'm going to do to show you how easy Logfire is to use is I'm going to take that app and I'm going to instrument it with Logfire. So if we come over here to I'll shut it down for a minute. I'll take you to the code here. First thing, so this is our very simple app. We have, if I start here, Fast API app, we use Fast UI to do the simple UI, and the interesting bit is in this main router where we have logic for generating the image and showing the list of images. So the first thing I'm going to do is I'm going to install Logfire. So actually, I'm going to get rid of my previous configuration. You can ignore that bit. Right. So I'm going to do UV add Logfire. And as well as Logfire, we want to be able to instrument the Fast API and async PG, which we're using to store the data. So I'm going to add Fast API as dependency groups and async PG. UV goes away and installs them. And now I can come over to, well, the first thing I'm going to do is I'm going to connect Logfire to one of my projects in Logfire. So if you come over here and I open up Logfire, the dashboard. And I open up the talk one, which I was working on a bit earlier. Now, this is fine. We have like a blank screen. We want to get some data into here. So to do that with Logfire, the simplest way of setting it up is I'm going to use UV run Logfire to get access to the CLI. And then I'm going to go projects, use, and obviously, I do a lot of this, so I have lots and lots of projects. You'd normally have 2 or 3 here, but talk is here at 32, so I'm going to use that. And now this project is now linked to the project I was showing you in the UI, and that's done via this .logfire directory, which has a file in it, which has the credentials, which logfire will go and look for. But I'm now ready to start instrumenting my app. So the first thing I want to do at the beginning of my application is logfire.configure. So if I do logfire.configure, and now the next thing I want to do is instrument fast API. So underneath my fast API app where I've just created it, I'll do logfire.instrument fast API. That takes app as an argument, and a logfire.instrument async PG. That doesn't take any arguments. And lastly, obviously we're using OpenAI to generate the image, and we want to get the instrumentation for that. So I'll add here logfire.instrument OpenAI, and you can see already that we have lots and lots of different instrumentations which PyCharm is offering me. But on this occasion, I just want to use OpenAI. So that's what I added here. 1, 2, 3, 4, 5 lines of code. And immediately when I come back and run my app, you'll see immediately we get this line printed out telling us where the data should be. And if I open that, you'll see immediately we're getting, well, they look like logs, but they have a duration, so data into logfire. And if I now go back to my app and I, let's say, reload the base page and then look at the list of images, open an image, and we look inside logfire, we'll see those requests coming in. And this is the logfire live view, and this is where you spend a lot of your time. So if we look in that last view there, that was the request where I got the details about a particular image. You'll see inside the request, we have fast API arguments, which is very useful for working out what your function was called with. But obviously, we work with any other web framework. And then we instrumented async PG, so we're seeing our individual queries here and how long they took. So you can see this query here to get the particular image took 1 millisecond. And if I come back now and I go and generate another image, let's see if this one decides it wants to be considered obscene. And you'll see here, even as that request is ongoing, we can see it happening inside the logfire UI. If we let it finish, and we get our, suppose that doesn't look at all Francis Bacon, but we get a picture of a horse. Great. But the interesting bit in terms of logfire is we come in here and we look inside the generate request. You'll see that the generate request took 12 seconds. So that was almost all inside this call here to OpenAI, to asking it to generate the image. And if we look at details on that particular span within logfire, we have a preview of the animal, and we have basically this secondary prompt, which is what OpenAI uses to enrich the image. And I think it's this intermediate prompt which is sometimes obscene. So it takes your very simple prompt, tries to build a more complex prompt. That more complex prompt is then sometimes seen as being obscene, and you get back an error. But obviously, it's not just OpenAI that we can instrument. We can also see, as I say, database requests in this particular case. But the most annoying thing at the moment is we have, when we start up our app, if I start it up again to show you, we have these, whatever it is, 5 or 6 different database queries which are being printed out as top-level spans, as traces. We'd like to put all of them into a trace. So that leads us on to more manual tracing with logfire. So if we go into database and we see this prepare database function, this is where we're doing all of the stuff, setting up our database when we start the app. So we can wrap this in logfire.instrument. And now, when we start our app, and it will have been restarted, you'll see in here that now, instead of seeing each of our database queries going through as individual traces, we now see them all nested within this trace. We see how long that took, and we can see how long each one took. But let's go on one step further, and let's try, well, actually, let's look at this request here, which is getting the list of images. So you'll see here, this is looking weird. We've got 55 different, can you see that on screen? Is that clear enough? You can see we have We open up this particular trace and we see, whoa, so we're doing loads and loads of queries. So immediately, without having our page, our screen like enveloped by hundreds of different logs, when we drill down, we can see where they're all coming from. And sure enough, we seem to have lots and lots of repeated queries going on, trying to get data from the database. So that's a great hint that we will go and have a look at our code there to see why that's happening. And if we, sure enough, if we go and look at it, this is the query in question. Okay, so we're doing a database request to get the list of IDs of images, of the first 50 images, with a limit and an offset. And then we're iterating over each individual one of them, getting the rest of the data. Now, if you're used to writing apps like this, you'll see this as being very dumb. Why would anyone do this? If you're using an ORM like Django or SQL Alchemy, it's very easy to do this. You access one extra attribute on every iteration. Suddenly you have loads of requests going on. So this is a pretty easy one to fix. Instead of making 50 different requests, we make one but get all of the data. And so if that restarts, and we come back here, and we get the list of images again, once that comes through, you'll see, awesome, we only now have 3 requests, 3 queries to the database. But something weird is going on. Actually, it'll happen more if I reload that again. We can see here that this request that we just rewrote to get the first 50 details about the first 50 images from our database are taking a weirdly long time. This is taking 17 milliseconds, which running locally and just getting 50 images is way too long. So this is an excellent, again, just looking immediately at the live view, we can see something where we're like, this is probably wrong, and we can go and investigate why that is. And so if we go across here and we look at our code, and we look at how we've defined our database, here's our table definition. And if you spend your time writing SQL, you will immediately see the problem. We're sorting on timestamp, but we've got no index on timestamp. And so instead of me like writing out a migration, let's go and manually add that now. So if I do pg cli, connect to the database, I look at our images table, you see again the fields, but you see there's no index. And if I, well, on this occasion, pg cli is being too clever by half and telling me the query that I've run half an hour ago. If I go and create that index, if I come back and run that again, I come back and I load the images. I'll load it a couple of times to let FastAPI load properly. What was the time before? The time before was 27 milliseconds, and now getting those 50 images has come down to 4 milliseconds. So this demonstrates not just how you can use Logfire. You can imagine debugging this problem in production, but also you can do it locally to immediately see how long things are taking. And thereby accelerate the process of both understanding where things have gone wrong and where things are slow. And what we haven't got in this case, because now the API is refusing, well, I'll see if one more time if it's going to generate me an error. Go on, this time I'd like it to do an error and it's not going to. But if we were able to get it to generate that error again, you would be able to see details of the exception, where it's been handled and which particular requests it was within. But Logfire can do a lot more than this. So one of the things that makes Logfire particularly powerful is we allow you to write SQL directly against your data. And so that means that you can, of course, use the canned dashboards and alerts and live view that we have, but you can also go and do whatever query you like. You can effectively use Logfire to do analytics against not just your application, but how people are using your application. So one example of that, we might want to ask what animals have people wanted to generate images of. So if we went into our generate image that we had just here, you'll see within FastAPI arguments, again, one of the nice features of Logfire, we have nice details of what's going on within of the FastAPI arguments. This is a Pydantic model, but that's being displayed nicely with a model name, stuff like that you wouldn't get with other solutions. And so we can go and copy paste the query to get to animals. We can come across here to Explore view. I'll start a new tab, and we can then use that to go and query that data. So if I can write, as I say, raw SQL to query my data directly from here. So if I did select, I want to get basically a table of what animals have been requested and how often they've been requested. See if I can write properly. And we want to say we only want to get spans where the animal attribute has been set. And we want to group by animal, order by count descending. And, oh, I wrote something wrong. What? Sorry, say. To the right. Oh, as. Thank you. And so we get back effectively, we can use that to then go and introspect our data, like effectively Logfire as a database, as of course it is. And I haven't had time to set these up today, but you can then use that to go and build dashboards that you can either view or share with your team to view. And you can also set up alerts, again, by writing SQL to ping you on email or webhook or via Slack when things go wrong. I want to leave some time for questions. I don't know how long we've got. 5 more minutes. Well, I think let's go to questions now, and then I suspect there will be some questions, and I can go into them in more detail. Oh, and having said I will go to questions, I will actually come back to the presentation and just say, I've just got 2 more slides. Sorry, having said. So first of all, I obviously gave a demonstration with Fast API, but we have integrations with lots and lots of different libraries already. You can also use Logfire with other languages because we're built on top of OTel. We have examples of a few there. But the real point I wanted to get to is, so we came out of beta a couple of weeks ago, but we have this coupon code, Pycon PT 2024, which will give you, I think it's $200 a month off Logfire for the next 3 months if you use it before the end of October. But also, we have a very generous free tier generally, so you can get started with Logfire and even use it on small production applications without paying anyway. Obviously, when you go over 10 million spans a month, then you start paying. Sorry, take 2. Now I can take questions.
Let's give Samuel another round of applause. Thanks for sponsoring. And now the floor is open for questions.
Hey, thank you. Great presentation. My question is, what if I'm trying to install this in a production app that is getting like a whole lot of requests all the time? So the view that you showed, that's really useful to debug if it's just scrolling and scrolling and I can't see what's going on. Do
Absolutely.
you have a solution for that? How do you handle it?
Yeah, absolutely. So the first thing to do is basically, I mean, we have people sending, what's a good, definitely like millions of spans an hour. And that live view, you know, you can see stuff scrolling past, you can pause it, and you can go in and look at something that you see being slow. But like, obviously the next step is effectively to apply a filter. So like if I look over the last like 6 hours and then I can level is greater than info is a like very simple filter, and I haven't had any errors. Maybe I have in the last 12 hours on that project. Now let me go to another project where you'll be able to see that. So this is a demo project that's like running all the time. So you'll see data coming in, and if I do level is greater than info, and then look over like the last 6 hours, you should see errors coming in, and so you can then start filtering down, or you could filter, as I showed you before, onto a particular user. So maybe I don't think there are users in this app, but like if you clear the filter, you'll see like these requests here. You could say, I specifically want to see requests to this endpoint. I can, that's not worked. So I want to see requests to information about this particular city, let's say. I can do that, and that will start showing me requests to a particular endpoint. So over a certain limit, you want to start filtering. And then if you're concerned about cost, the next step is, head sampling is effectively randomly choosing, I'm going to cut off 90% of my data and 10% is enough to see. Then we have tail sampling, which is more powerful, where you only send through traces where some threshold is met. So they're slow, or they have some spans of level error, or whatever you want it to be. And that's a very powerful way of getting the kind of the interesting bits when you get to that scale.
Hey Samuel, thanks for such an interesting product. I was wondering, because you demoed let's say, performance diagnostic possibility. Yep. So I suppose that my application will have some overhead when it ships information into Logfire.